The HTM-RL integration pipeline is a configurable model training system for adaptive trading. Traditionally, most trading models are supervised and trained once on historical data and deployed as is. Financial markets are non-stationary, noisy, and constantly shifting. A model trained on last year's patterns may be completely ineffective today. So what was needed were models that continuously learn and adapt in real time. Systems built for evolving, noise-heavy environments that don't require constant retraining from scratch.
Our solution, HTM plus reinforcement learning. Reinforcement learning forms a modular pipeline where hierarchical temporal memory processes context-sensitive data into sparse distributed representations. The agent refines its strategies by requesting the brain to update this internal policy based on reward feedback received from the gymnasium market environment. This architecture allows the RL component to act as a downstream consumer of the stable patterns found by the HTM layer, ensuring that policy updates are mapped to established temporal features. Pipeline architecture. The input layer. It detects file type, loads data into a data frame, normalizes timestamps, fills missing values, and validates structure. The encoder layer converts raw numerical data into SDRs, which is the format HTM uses to process information. The agent layer. This builds a brain where the HTM model learns temporal sequences and patterns in the data. It also creates a custom gymnasium environment so the RL agent can learn trading strategies through trial and error. Results and validation. We have data ingestion. Successfully detects CSV input, normalizes date, time, and numeric columns, validates dataset structure. We have SDR encoding. Accurately encodes and decodes scalar values with confirmed confidence of 1.0. HTM brain. Functional brain construction with configurable parameters, including resolution, spatial pooling, and temporal memory. RL training loop. Working with gym trading environment with full training loop execution.
For the practical application, a developer at Intellect imports the HTMRL pipeline, points it at a historical market dataset, configures hyperparameters such as learning rate, sparsity, and reward structure, and runs end-to-end training with automated logging and performance reporting.
Great, now we will go over a final demo of our pipeline. I'm going to share now. Okay, so you can see up here, we have imported our entire module as just one package. And so here we have our log tools being shown as you can create your own logger. You can send it custom messages, however you would want to track it. Here I'm also just printing the version of our current package. So we need an input handler, as we have discussed. So here's how you would actually access it through our pipeline and create an input handler. And here we are saving data from a constant path that we've set within the pipeline. And then here's parameters that you need to create our encoders when you want to use our encoder tools. So here you see we have an encoder, a random distributed encoder. And then here you can see this is the pipeline pulling up. You can see all of the encoders that we have created. Okay, so we're going to comment this out. And then moving on, we need to grab just one sample of this so we can show a demo of it actually doing the job of encoding. So that's what this is doing. And then we're going to show you a graph of what those bits look like after they're encoded. And if we want to use our agent, like we've talked about, we can create a trainer using our agent tool. And then we just instantiate a trainer and pass it the things it needs. It needs a brain. And then we, again, build fields to build the brain, and we just pass everything it needs. And then we're going to actually show you just one column being trained on that one small data set. So here we go. Yeah, it only read 10 rows, so it did it pretty quick. And now we can see what this actually looks like. So this is what the encoded data looks like as a string of bits, a bit vector. with blue being a 1 and white being a 0. Okay, so now it's going to take brain steps. It did it pretty quick because we're only doing a small set, but you can see our pipeline is reporting, hey, the brain took steps on this data. And then this final graph is just showing you active columns within the spatial folder. And that concludes the demo.